Let's take a look at this example. This example, the block is attached to the spring, moving along the smooth plane, a smooth inclined plane like this, and the surface, the smooth surface is has a 30-degree from the horizontal plane. Okay, and the problem gives us that when S equal to 0.6 meter, the spring is not stretched or compresses. It means that 0.6 meter is the unstretched position on the left point for determine the work done of the spring. Okay, the block has a mass of 10 kilogram. Okay, and it is subject to a force of 100 Newton, and it has a speed of 5 meter per second down the smooth plane. Okay, this is the velocity. Okay, this is the velocity, initial velocity v1. Okay, we would like to find the distance s when the block stop. Okay, when the block stop, it means that at the final position, velocity at the final position is 0 meter per second. Okay, so because this problem is involved force, velocity, and displacement, so then we will now apply the principle of work and energy to determine the displacement S. Okay, that is the principle of work and energy stated by T1 plus summation of U1 to 2 is equal to T2. Okay, so according to this, we apply the principle of work and energy between position 1, that is say that S1 is equal to 0.6 meter, and position 2, that is S2, that we don't know now. Okay, and we know that the normal force N, that is along this, okay, does no work since it's always perpendicular to the displacement. Displacement is for this case it goes down. Okay, and according to this, we will see that it has the force mg. Okay, and we have the normal force that is perpendicular to the surface, to the contact surface, and it's perpendicular to the displacement, so it's does no work. Okay, and we also have the force, applied force 100 Newton. Okay, so the work of force, is come from, if we consider the body, the particle block, that is we have the weight. Okay, the normal force and the applied force, and also we have spring force. Okay, and if we define that the displacement is go down as a positive. Okay, so the work done from normal force is equal to 0. It does no work because it's perpendicular to the path of the motion. Okay, the force, the work done from this system is composed of three. It comes from three force, that is the applied force F, the weight mg, and the spring force. Okay, so according to this, for the weight, we have to decompose the weight into the direction of the displacement, that is should be mg cosine theta, which is the angle theta here. Okay, according to we know that it is theta, right? So then it should be 90 minus theta. Okay, so then it should be theta. Okay, so then we have the components of mg is equal to mg sine theta. Okay, for this case. Okay, so then we consider the first work from F equal from the applied force F equal to 100 Newton. Okay, because the force is constant, so then the work done by this force is equal to 100 times the difference in position, that is moving from S1 to S2. Okay, S2 is the unknown, keep it. Okay, but S1 that is the we set up is to be 0.6 meter. Okay, that is the first position. Okay, and the work done of the block weight. Okay, work done of the block weight is equal to mg. This is the mass mg. G is 9.81. Sine theta, theta is 30 degrees. Time S S2 minus S1. Okay, and then it's become this term. For the work of the spring force, okay, we know that the work of the spring force US is equal to minus half K S 2 square minus half K S1 square, right? From the formula that we have studied last time. Okay, but we have to know that S2 and S1 is measured from the unstressed position. From the unstressed position, that's now for this problem, unstressed position is 0.6. So then for this case, we can write the work of the spring force by this equation, that is a half k is now 200 Newton per meter. Okay, and S2 now actually it is the difference of the second position minus the unstressed position, that is 0.6. Okay, and for the first position, that is actually it is start at the unstressed position, that is 0.6 also. So then it means that the last term is become 0, right? Okay, so then the work done of the spring force is just has only this. Okay, that is become like this. So we apply this term into the work and energy equation. So the first term is the kinetic energy. Kinetic energy at the first position, we know that it is equal to a half mv1 square. A half is 0.5, m is 10 kilogram. And the initial velocity, we know that from the problem it is equal to 5. Okay, so then it's become this term. And then after that is the summation of the work done for 3 force that we already derived. We substitute into this. Okay, and it's equal to T2. T2 now, actually it is equal to half mv2 square. But from the problem, tell us that at the second position, the block is stopped. So then V2 is 0. So then kinetic energy and the final position is become 0. So after that, it lead to this equation. And after we solve this quadratic equation, we can solve for S2 minus S1. According to this equation, we obtain S2 minus S1 equal to 2.09 meter. So then we can determine for S2 that is become 2.69 meter. Okay, let's complete this problem. So then let's take a look for next problem, that is a block A and B. block A has a weight of 60 pounds and block B has a weight of 40 pounds. The coefficient of kinetic friction, mu K of the block and the incline is equal to 0.1 for both. Okay, neglect the mass of the cord and pulley system. Okay, we do not consider the mass and the, the mass of the cord and the pulling. Okay, and we would like to determine the speed of block A after block B moving up of 2 foot. Okay, and the system is start from rest. Okay, so first we have to set up the kinematics relationship. Okay, and we know that from this picture we set up B point, that is the fixed point, okay, as the reference, and then we measure from the topic of absolute motion analysis of two particles. Okay, we set up the reference to this point and we measure from this reference point to each box, that is mean that downward to block B is the positive and downward to block A is positive also. So for this case, downward is the positive direction. Okay, and after that we write the constraint equation, that is the cable length is constant for this case. It's composed of 2SA, that is the green line, and SB, that is the red line. Okay, so then for this constraint, we can rewrite the constraint equation like this, that is 2SA plus SB equal to the length, the constant length. Okay, and so then it means that when we find the difference in length of this term, because length is become constant, so the difference of length is become 0 because it's keep constant. So then it means that we have this equation, that is 2 times the difference in displacement of block A plus the difference in displacement of block B, difference in position, sorry, which is a displacement. Okay, and this becomes 0. So for the problem give us that the difference in position of block B is 2 foot upward. Okay, 2 foot upward. B is moving up, but we set up the positive side convention from the reference is downward as a positive. So then delta SB should define in negative because it is opposite to the positive direction that we set up. And because we delta SB is negative, okay, according to this equation, we get delta SA become the positive 1 foot. Okay, in the same manner for velocity, when we take the derivative of this equation, we obtain the relationship of velocity of two box, that is 2VA plus VB equal to 0. And now we found that VB equal to minus VA. So it means that when B moving down, A will moving up, or when B moving up, A will moving down. Okay. So because this definition of SA and SP positive motion for each box is defined as a downward. Okay, it follows the positive sign convention. So when we consider the free body diagram of each block, okay, we can find out the free body diagram of each block can be written like this, okay, and according to this picture, we found that NA is equal to WA cosine 60 degree, and NB is become the weight B cosine 30 degree, okay, and according to this, we use NA and NB to determine the friction force, okay. So after we apply the principle of work and energy to the system, and the block start from rest, it means that VA1 is 0, okay, and VB1 is 0 also. So the kinetic energy at the first position becomes 0, and the work done from the first position is composed of the weight, okay, in the directions of inclined plane, that is WA sine 60 degree, okay, minus 2T, that is opposite to the downward direction, okay. We set up delta SA as downward as a positive, okay, SA downward as a positive. Oh, sorry, downward is this direction for A, okay. And in the same manner for B, for block B, downward as a positive direction, okay, and the from the force that form free body diagram, we found that for block A we have the weight, and we have two tension, 2T, right? Okay, because it's composed of two tension. When we cut off this, okay, we have the block here, and this is the pulley. We have two tension, it's become 2T, okay, and according to this line, we have mg sine theta, okay, here, and uh, we assume that the friction is up because we set up the downward as a positive, right? Okay, and for B, okay, for B, we know that is moving down, okay, when we set up, well, because the problem give us that B is moving up, so then the friction should be moving down, okay, because the given motion that's from the problem, okay. So according to this, when we form the work done for each block and follow the positive sign convention, okay, follow the positive sign convention, we found that the change in position for this case, delta SB is become negative 2 foot, and VB, okay, it's become minus 2 VA, okay, and NA and NB is become like this, okay, but delta SA is become 1 foot is positive because we assume that delta SB is moving up, okay, and after delta SB moving up, so then delta SA is moving down, it is a positive one, and after we substitute each value into this equation, we can solve for the velocity, the final velocity of block A, okay. So from this equation, we found that the tension term is cancelled out, Okay, and we can solve for VA, that is VA2, that's become 0.771 foot per second. Let's complete this problem.